Alright, welcome back to Mr. D's Please Physics tutorial. Let's do number 22 right now. Read it as I read it. It says an athlete runs 110 meters across a field, which is level, at an angle of 30 degrees north of east. What is the north component of this displacement? Alright, let's tackle this. For this one, it's so simple if you understand how to find the x and y components that I would let you skip using the GFFS. But let's just use it to stay consistent. So, runs 10 meters, 110 meters across a field at an angle of 30 degrees north of east, and that fits into what we always go off of, the east, so we're not going to put north of east. Then you got to tell me, what is this 110 meters? Write it down. Alright, hopefully you said that was displacement, and hopefully you know he doesn't run up into the air, so it's going to be change of x. You can't just put x there because that's a point, not the difference in position. So that's an x would just be a position. So you've got to put that delta sign there. Now it says, what is the north component of the displacement? So find. Alright, to help you out here, let's just do a little diagram. North, east, west, and south. So it asks for the north component of the displacement. Okay? Let's draw the vector now. So we have, that's a little too steep. Let's just reduce the angle a little. There we go. We'll label this 110 meters. And it's going to be at 30 degrees north of east. And what we want to find is the north component of the displacement. Alright, so how much of this 110 is going up? Because north is up. So when we do this, we could quickly put some dots here to get our 90-degree triangle. That's the y right here. And here's a little box to show 90 degrees. So let's quickly look at this. Here's the angle. The x is in the adjacent position. Alright, the y is in the opposite position. So, once again, let's write down SOHCAHTOA and let's figure out which one do we use. Alright, so what we want to find is the north component of the displacement. So that's the y. Okay, so quickly we found it. It's got the opposite in it. Alright, so we can use that formula. So we want to find the y component. So the y component equals, so the formula, we just said we're going to use the so. Alright, so that's sine angle equals opposite over hypotenuse. Now, I want to find out what the opposite is, so we got to get rid of the hypotenuse. So, multiply both sides by hypotenuse to cancel it out. So, hypotenuse over here will cancel it out. Then hypotenuse will squeeze in over here. And so that's our formula now. The opposite, which is the y, so we can relabel that. Alright, is going to be the hypotenuse sine angle. So let's solve that. Alright, do it right now. Plug it in. Alright, hopefully you plugged in the calculator correctly and hit the right buttons for sine 30 degrees. You should have come up with an answer of 55 meters. So, that you would just say is the y, 55 meters. But we use sig figs in here. And you say to yourself, how many sig figs do we need? Okay, so this 110 has 2 sig figs. Alright, the 30-degree angle, we'll say that is an exact number, so we'll just stick with 2 sig figs. If you thought that the 30-degree angle was measured, then you'd say 1 sig fig. Let's just say you went with 1 sig fig. If you went with 1 sig fig, you could have gotten 60 meters. But that angle, if it is exact, we just use this for the sig figs. Alright, let's get on to the next video.